Assalamu alaikum. This is chemistry 11th, and today we are going to discuss the alternative derivation of this ideal gas equation. In our previous lecture, we have already discussed that how this ideal gas equation can be derived by applying this Boyle's law and Charles law on a given mass of a gas. Now, as far as this alternative derivation of this ideal this gas equation is concerned, this can be derived by applying by applying the combined or this effect of this Boyle's law, Charles law, and Avogadro's law. So by combining these three laws, we can derive this we can also derive this ideal gas equation. Now, as far as Boyle's law is concerned, as I have told you that this law is it gives us the relationship between this volume and the pressure of a given mass of a gas under the conditions of constant temperature. And we see that and this law states that volume of a given mass of a gas, it is inversely proportional to its pressure. You can see here I have shown that V is inversely related to its pressure under this constant this temperature and the number of moles. Now similarly, then we have got Charles law. As you know that, as I have already told you, that this Charles law, it gives us the relationship between this between the volume and the temperature of a given mass of a gas under the conditions of constant this pressure and constant this number of these moles. Now, this law is stated that volume is directly proportional to its absolute temperature at this constant pressure and number of moles. Now, then we have got this Avogadro's law. As this Avogadro's law, I have already told you that it and this law can be, as I have told you, that this law states that under the similar conditions of temperature and pressure, equal volumes of all gases contain equal number of molecules. That means 22.4 liters of any gas at STP, that is under the conditions of 273, that is standard temperature pressure, and a pressure of 760 mmHg, and that is under that 22.4 liters of any gas at these conditions contains Avogadro's number of molecules, that is 6.022 into 10 to the power 23 molecules, irrespective of the nature of this gas. Now, by combining these three laws, that is Boyle's law, Charles law, and this Avogadro's law, we can also derive this ideal gas equation. You can see here, this is V is directly it is related to this is N, that is the number of moles, and it is directly related to this temperature, and it is inversely related to pressure. So we can also write it like this PV is equal to nRT. Now, as far as I have already told you, this R, it is the where P is P is pressure, V is volume, and N is the number of moles of the gas, and T is temperature, and R is called the universal gas constant. Now you can see that this universal gas constant has got a different units under different conditions. Now this gas equation, this can be also used to find the volume of a gas under specific these conditions of temperature and pressure, provided its volume under other conditions are known. So this can be done by applying this gas equation. We have got this is P1 V1 over T1 is equal to P2 V2 over T2. So this is how we can find out the volume of a gas under certain specific conditions of temperature and pressure, when the volume of volume of the gas under other conditions is known. So this is an alternative derivation of this and this gas equation. Then as far as the units of this gas constant or concern, we will discuss the units of this gas constant in our next lecture. So this is for today. Thank you very much.